The star in question is called SDSSJ 102915 plus 172927. For the record, I much prefer simply named stars as opposed to ones named like this one. The odd names do serve a purpose though, as they are typically coordinates for where the star can be found in the sky. In 2011, a team of European astronomers discovered this star in the constellation Leo. It is a small star, only about 80% the size of our Sun, and is believed to be around 13 billion years old. Since the universe as we know it is itself thought to be around 13.7 billion years old, this is considered one of the oldest surviving stars. Nothing is particularly unusual about this star, except that according all of our theories, it shouldn't even exist. The star is made up of 99.99993% hydrogen and helium, elements that are too light to condense and form a star on their own. When these figures are put into any star formation supercomputer simulation, the result always comes back that such a star is not possible. Astronomers are puzzled as to how such a star could have formed without the aid of heavier elements. Research is ongoing. SAO 206,462 gained the attention of astronomers in 2011. What surprised them was not the star itself, but what surrounded it. It seemed to have spiral arms rotating around it. Now spirals are no strangers to space, being one of the common formations for galaxies, but scientists have never observed one rotating a star before. The cause? It's still a mystery, although a widely accepted theory is that gravity from planets, forming in the dust which orbits the star, are responsible for the features. However, there is not enough evidence to support this theory. Until planets are actually detected, it is likely to remain a mystery. Messier 4 is a globular cluster, about 7,200 light-years away from Earth. If galaxies had human life cycles, this one would be an old-timer at 12.2 billion years. While looking at stars in this particular galaxy in September of 2012, a team in Chile found a star rich with a material called lithium. In 2005, the Hubble Space Telescope zoomed in on the galaxy's core and discovered a blue, pancake-shaped disk rotating dangerously close to the black hole. Further analysis showed that this was not just hot dust. The glow was coming from millions of young blue stars. These stars are zipping around the black hole at more than 2.3 million miles per hour. That is fast enough to circle the Earth at the equator in only 40 seconds. The thing about this disk is that, given what we believe we know about the tidal forces around black holes, they should not exist. The gas which formed them, and the stars themselves, should have been torn apart by the immense gravity of the black hole. How they were able to remain intact in such a close orbit, remains a mystery. In 2009, Koel Hellier of Kiel University discovered that WASP-18 had a planet. Dubbed WASP-18b, the planet is slightly bigger than Jupiter, but has about 10 times its mass. This is just below the mass that would make it a brown dwarf, which is a star that failed to initialize. What puzzles astrophysicists is that the planet orbits less than 2 million miles from its parent star. By comparison, Mercury is nearly 36 million miles from our Sun. WASP-18 is so close to its parent, that it completes its orbit in less than 23 hours, and its surface temperature is around 4,000 degrees Fahrenheit, 2,200 Celsius. Being so close, the planet should eventually fall into its Sun, yet it has survived already for about 680 million years. Given the mass of the star it orbits, this planet should have been consumed long ago. How a planet was able to form and remain in a location where planets were thought unable to exist, is a question that continues to perplex astronomers. A total of 3 planets and 1 dwarf planet orbit this pulsar. Thinking they must be common, scientists began looking at other pulsars for planets. However, only one other pulsar was confirmed to have a single planet orbiting it, showing that they are indeed extremely rare. The process by which such planets are able to form is still not well understood. The most accepted theory is that the planets formed a little like our own, from a planetary disk that originally surrounded the star. However, any planet-making material and dust should have been thrown billions of miles out into space by the supernova explosion. How the gas and dust was able to return to the remaining pulsar, become tidally locked, and contain enough material for the formation of a whopping 4 planets, remains a mystery. The rogue planet. CFB-DSIR 2149-0403 is classified as a brown dwarf. These have failed to initialize nuclear fusion in their cores, and develop into real, burning stars. Only 4 possible candidates for the title of rogue planet are known to exist, the one in question being the closest to Earth at an estimated 130 light-years. Without a large star to orbit, the motion of the planet is influenced by other stars in the AB Doradus star group. This doesn't mean that it travels through space in any sort of straight line, a common misconception about rouge planets. But just how a planet is able to go rogue remains a mystery. TYC 8241-2652 is located 450 light-years away in the constellation Centaurs. It is believed to be around the same size as our Sun, but a mere child, at 10 million years old, compared to our 4.5 billion-year-old star. From 1983 to 2008, astronomers searched a bright ring of dust around the star for possible planet formation, believing they were getting some insight into how our own solar system formed. But when the star was due for a checkup in early 2009, the once visible, glowing disk of dust was gone. It did not leave behind any planets, or any signs as to where it had gone. It had quite simply vanished. Scientists were baffled. When asked about it, astronomer Carl Melis simply stated, "We don't have a really satisfactory explanation to address what happened around this star."